Have you ever written code that works today, but after 3 months, even you do not understand it? Or when you change one small thing and the whole application breaks? That's happen because you do not follow proper design principle. Today, I am going to explain one of the most important concept in software development, solid principles. If you understand solid principle, your code will become clean, maintainable, and scalable. And trust me, every good Java developer, Spring Boot developer, or full stack developer must know this. Let's understand Solid in the single solid principle. Solid is a set of 5 design principles help us write clean and maintainable code, introduced by Robert C. Martin. And Solid is used in Java, Spring Boot, and microservices. Solid S understands single responsibility principle. O stands open closed principles, and L Liskov substitution principle. I interface segregation principle. D is the dependency inversion principle. First is single responsibility principle. Single responsibility principle says a class should have only one reason to change. Means one class, one job. It is the bad example because this class contains so many responsibilities like save user, send email, generate report. So it is not follow the single responsibility principle. Correct example is here, like user service contains the save user related functionality, email service contains the email related functionality, and report service contains the report level functionality. So it is easy to maintain and easy to test. It is follow single responsibility principle. Second is open closed principle. Open closed principle says the open for extension but closed for modifications. You should be able to add new features without changing old code. Meaning add new features without changing existing code. So wrong example is here, like it is the bad example. Payment service contain the integration based on the type. So one class contains all the integrations like UPI, credit card, PayPal, and other things. What happened in this? If client says please add PayPal payment in my applications, so what you to do? You again modify this class like this. Else if type is equal to this and functionality we need to implement here. What problem in this? Like every new payment methods added the same class. Risk of breaking existing logic. It is not scalable. This violates the open closed principle. Correct example is here. Create a interface like payment and it is implement in every class, payment related class like credit card payment implements payment, UPI payment implements payment, and call it in the payment service. If I implement it in this way, then now client says add PayPal integration. Please integrate the PayPal implementation. So you do not need to modify old class. Just create new class and implement the payment and create the functionality related to the PayPal payment implementation. L understand the Liskov substitution principle. Liskov substitution principle says the child class should we have like a parent class or subclass should be replaceable with the parent class. If child class is break the behavior of the parents, it's wrong. Like this is the bird class. This bird class says the flying means should we fly? If not fly, then it's break the rules. So like here, penguin extends bird. It is overloaded, like override. Need to implement these things, but penguin is not cannot fly, so it is not replace the functionality of the parent, functionality or behavior of the parent. So it is the wrong design. This is the better design. Create a interface bird, every bird eat. So we can implement in every class because every bird can eat. But interface flying bird, extend the bird flying. Sparrow implements the flying bird, void eat. Uh, this is the flying bird. Flying bird can eat and fly both. And penguin cannot fly, so we extend implement from the bird. So this thing is here. Second is the interface. I understand the interface segregation principle. This says don't force a class to implement things it does not used. Like a big interface contains like work, eat, sleep. Like we need to create a robot implementation, but it does not eat. So we need to separate the interface like workable and eatable and keep interface small and specific. Last is the dependency inversion principle. Dependency inversion principle says the high level modules should not be depend on the low level modules. It's depend on the abstractions, not concrete class. This is the bad example. Bad example, like payment order service directly depend on the MySQL database. So like high level module is depend on the low level modules. If tomorrow you change the database to MongoDB, you must modify the order service. This is the tight coupling. So today we understand solid principle in simple word and practical way. Remember this one line: write code that is easy to change, not easy to break. If you follow solid principle, your code becomes flexible, your project becomes scalable, and debugging becomes easier. If you found this video helpful, like, share with your developer friends, and subscribe. See you in the next video. Keep coding and keep growing. Thank you.